Alright, third and final topic is electronegativity. Electronegativity describes how much an element wants to gain electrons. Ionization energy was how tightly you were holding on to electrons. With electronegativity, it's how much they want to gain more electrons. It turns out, though, it's based on the same idea of ionization energy. In other words, the nucleus has a strong pull based on its positive charge, right? And if it has a really strong pull, it will attract electrons from other atoms. So if an atom has a high ionization energy, that means that it also tends to have a high electronegativity. They come hand in hand, with one exception. Okay? So let's practice. Well, again, electronegativity is highest at the top right, so here's where it's high, and then it's lowest down here. Okay? So you're going to rank the following elements from highest electronegativity to lowest on your own. So go ahead and pause it and try it on your own. Okay, if you didn't like me from before, I went ahead and circled. So cobalt's right here, silicon's right here, calcium's over here, francium is down here, fluorine is up here, and neon. Okay, so based on this idea, the top right of the periodic table has the highest electronegativity. So that would lead me to believe that neon would start us off. But there's a problem. If you remember when we were talking about stability, neon is a noble gas. It has a full valence, meaning it has 2 S's, 2 S electrons, and 6 P electrons. So it has a full octet. It's happy. It doesn't want extra electrons. So it turns out with electronegativity, you ignore group 18, also known as 8A, meaning electronegativity does not apply to these guys over here. Okay, so what that means is I can ignore neon, and my highest electronegativity is going to be fluorine. From there, I go down and to the left. So next would be silicon, and then from there would be cobalt, and then from there would be calcium, and then from there would be francium with its lowest electronegativity. Okay, the last idea I want to hit with electronegativity is how does this factor into what we've learned about ions? Well, with ionization energy, we said that these guys to the left, the metals, tend to lose electrons, becoming positively charged ions. If you're to the right of the staircase, meaning over here, these guys do the opposite. They have high electronegativities, so they tend to gain electrons, which means when they become an ion, they have a negative charge. Okay, so let's put it all together before we finish. So if we take radii, ionization energy, and electronegativity, we combine them all together on one periodic table, what we see is that atomic radii, that pattern, is opposite the pattern for ionization energy and electronegativity. In other words, as we go down and to the left, atomic radii increases. And all you have to do is remember that France gets fat, right? Francium is the largest. It's down here in the bottom left. That means the smallest is up here. Ionization energy and electronegativity are the opposites. As you go up and to the right, they increase. Okay? So make sure that you complete your whisk. Make sure that you create your hot question. Hot questions can be questions about things that you didn't understand from this video, or it can just be a question that you feel like is a good quiz or test question on what we've covered. Alright, so get that stuff done, and we'll see you tomorrow.